All right, good morning, everyone. My name's Eric Westfall. Welcome to our session. I'm here with Glenn, and we're going to talk to you guys a little bit about some interesting topics today about how Amazon.com on the retail side of the house uses AWS services internally to do operations at scale, and specifically in this case in the cybersecurity realm. So it'll be an interesting talk. I will say this is the first one of these I've done where we start talking about Amazon.com things, so I'm excited for it as well. I work on the AWS side of the house and focus on the security and governance areas. So what I'll do today is we'll go through the agenda a little bit today, and really we're going to try to talk about some of the underlying predicate service underneath what Glenn's going to be talking about today, which is AWS Systems Manager, some of the components that Glenn and his team use to accomplish some of their goals. So I'll try to lay a very basic foundation for you guys, for anyone who's unfamiliar with AWS Systems Manager. We'll talk about how it works, some of the agent behaviors, and some of the few feature sets that Glenn will be talking about in more detail, so that when he gets to those topics, you guys know what he's trying to say. And then we'll toss it back over to Glenn, and he'll talk to you guys a little bit about what the challenges they faced internally were, what the problem statement is, if you will. And then we'll look at how they leverage these services to accomplish their underlying goal, right, which is installation of security, high criticality security agents on our hosts. And Glenn and I were talking earlier before the talk. One of the big issues is speed, right? When an instance lifecycle starts, some of these things are very high criticality. We need to get there fast. We need to get these agents installed quickly and ensure that they stay consistent through their lifecycle, right? So that's what Glenn will be talking about. We'll talk about how they leverage Systems Manager to accomplish those things, and we'll also talk about candidly, some of the challenges that maybe the service didn't have abilities to do out of the box, or they had to work around things because of scale. We always talk about things being easy until you try to do them at Amazon scale, and that's definitely true here, even in this use case, I think, is that if I told you need to install a security agent on some hosts, that's not a big deal until you have, 10 million hosts, and you need to do it in a P90 of X seconds or something. So it's an interesting issue, and I think Glenn will dive into a lot of the details about what that challenge looked like for them. And then we'll talk about the current operating scale that Glenn's team's working at. Again, one of those big problems. And then if we have time, unknown at this stage, but if we do have time, we'll certainly open up for some Q&A at the end if you want. So I'm going to hand it back over to Glenn to talk to you guys a little bit about the challenge and the problem statement, and then I'll come back and do some of we're going to do some live demos and things like that just to get out of PowerPoint as well. So cheers.
Thanks, Eric. Hi, everybody. My name is Glenn. I work in Amazon InfoSec. That's information security. And at InfoSec, we are constantly trying to raise the security bar. We can always do better, right? So a big part of this is the data that we collect about AWS resources, or resources used in internally owned AWS accounts. So we do a really good job of collecting data about resources, but an area of growth that we identified is that we could do more to collect information about stuff that's happening inside of EC2 hosts. So we can tell you about EC2 hosts, but we really could be doing more to tell you about what's going on inside of EC2 hosts. So we can tell you, when an instance is launched, we've gathered all this data so we can tell about machine images that are being used, how many are being launched, what times, et cetera, et cetera. But in order to get information about what's going on inside of the host itself, we want to install security agent software so we can get more information about that. Of course, the whole point of having information is so we can act upon it. A more general example would be if one of the teams at Amazon creates an S3 bucket and the bucket is publicly accessible, or if they have a dangling DNS or something, we at InfoSec want to know about that so we can either fix it for them or tell the team to fix it. So again, the whole point of this is to get more information about what's happening inside of EC2 hosts so we can increase the security bar. So recently, there was an initiative to install logging and monitoring software onto all EC2 hosts in internal Amazon. And one of our sister teams had developed a scanning platform that allows us to assess the vulnerability of endpoints and to drive the remediation. The platform leverages third-party agent software, and it requires us to make sure that the agent is installed properly, it's running properly, and it's configured. The agent collects information about the host, including open ports, user accounts, and the software running on the host. And then the data is analyzed by the agent for vulnerabilities. If a vulnerability is found, such as there's like an old library that needs to be updated or something like that, we ticket the host owner based on the severity of the issue, and it's cut with a standardized escalation schedule so that if the issue isn't fixed in an appropriate amount of time, then we escalate the ticket. So that's all great, but driving the installation of this agent proved to be a lot more difficult than expected. So we're dealing with hosts that are owned by countless different teams, and all these teams have different procedures, and installing this agent onto all of these different hosts across disparate teams was a bit of a wild goose chase. We tried our best. There were email blasts, there were ticket campaigns, we tried baking the agent into some machine images so that they'd be ready directly, but ultimately we were only able to get the security agent installed onto about 25% of all EC2 hosts in internal Amazon. Realistically, even if we had been able to do a lot more, even if we had been able to hit a lot more of the hosts, this type of effort just to get a single security agent installed is really unsustainable. I mean, you know, this isn't Amazon InfoSec's best friend race, so it's okay that we're doing the email blasts and the ticket campaigns even though people don't like them. But the point is that it's arduous for our customers, it's a lot of effort on our end, and it's just unsustainable. So our solution that we came up with relies heavily on AWS Systems Manager, as Eric said. So before I get into the solution, I'll pass it back to Eric, who will talk you through Systems Manager to give you a better context of the solution that we came up with.
Awesome. Thanks, Glenn. I'll steal that from you. Yeah, so we'll get into some of the basics of the service, and we'll dive into some more details. And as I promised, I'll get out a PowerPoint here, and we'll show some real-world examples and stuff like that as well. But one of the biggest things that we see with our customers, whether you're greenfield or you're a large enterprise customer, as we've mentioned, everything gets more complex at scale. But one of the things that we really want to do is drive that cloud operating model, that consistency, right? It's like whether it's on-prem instances, VMs running on VMware, it's EC2 instances, or it's a VMware running on like a third-party cloud like Azure or somebody else. What we want to do is have that consistent control plane. And so one of the biggest issues that we tried to solve in Systems Manager, and if anyone's been following the service for a while, it obviously used to start as EC2 Systems Manager. It is now AWS Systems Manager, and through the last few years, it has grown quite broad, right? There's a lot going on in the Systems Manager console if you get in there, and it can be a little overwhelming. But the reason that all this development is happening is because they're problem statements and problems that we're trying to solve internally, right? And as Glenn mentioned, this isn't the only problem we have, right, internally that we need to solve. And as we address those challenges, we try to eat our own dog food, if you will, and make sure that capability to drive that change is reflected in our service as well, because we know that customers are facing the same challenges that we are. And so one of the big things that we want to do in Systems Manager is, again, shorten that time to detect problems, right? Like if, again, an instance comes up and it doesn't have that vulnerability management agent, how quickly can we know that that's the case and then take action to remediate it? I don't want a human in the middle of it. I want to know that it happened and automatically remediate that issue, right? And that's where that automation and that task completion lifecycle management happens. And again, visibility is key here, as Glenn mentioned on this agent issue, right? If you've got hundreds of thousands or tens of thousands of accounts and millions of hosts in them, and you don't control most of those accounts or those hosts, getting that single pane of glass view and that observability window is important as well. So how do we go about that? Again, as we mentioned, hybrid environment management is key to Systems Manager as well. We'll talk a little bit about how that agent works quickly, but basically giving the ability to have that exact same experience as the operator, whether that instance is in EC2 or somewhere else, is key as well. And again, so we'll get into all the capabilities here, but we kind of have shifted our kind of focus in the way that we think about this and put these capabilities, if you will, into buckets like operations management for things like Ops Center and Explorer. This is that observability, visibility. How do I get insight into my environment? Application management, looking at things from a workloads perspective rather than an instance perspective. So things like resource grouping and dynamic tagging. Application configuration, right? How do I take versioned app configs and make sure I have a consistent ability to push those configurations out? Parameter store for things like key value lookups for environment configurations and sensitive credentials or API tokens. And then the last two are sort of where we're really probably be focusing most of our time today, which is in the actions and changes category, which is distinct from instance management or node management, in the fact that like Systems Manager automation or maintenance windows or change calendars aren't specifically limited to working with instances with an agent on them, right? Automation documents can run arbitrary Python code or shell scripts or PowerShell. We can make API calls. If, for example, Glenn mentioned things like S3 buckets or CloudTrail configuration. If you want to automate those things with Systems Manager, that is doable via Runbook, and we don't have to have an agent or an EC2 instance involved at all, right? Again, change calendars and maintenance windows there to reflect our ability to control safely how we go about operating at scale. And then lastly, the instances and nodes pieces, right? And this is where almost everything that Glenn's going to be talking about lives in this category, right? Whether it's data collection and inventory, run command to execute documents and scripts and complex sets of commands on instances, patch management, distributor. We'll talk a little bit about that today in more detail, especially given what Glenn's going to be talking about and how distributor might address some of those things for you guys directly as well. State manager associations for things like baseline compliance and remediation, desired state configuration, if you will. And then session manager for interactive shell access to manage instances without needing open ports, right? So no longer need to have SSH ports open or RDP ports open to get into an instance. We can do that without needing any of that attack surface opened. So I'll breeze through these relatively quickly, but we talked about one of the key things here is state manager. And state manager's job, as we state here on this slide, is really about desired state configuration. If I can boil a problem down to, is this true or false? And if it's not false, make it true, right? So imagine something like, in Glenn's case, agent A, some third-party security agent, must be installed on the instance, it must be up to date to the latest version available, and it must be in a running state, okay? If all three of those things aren't true, I want you to detect that it's not true, and then take some action to try to fix it, right? And I want you to do that relatively quickly. And one of the things we'll talk about with State Manager is that there are hooks inside the service that allow us to speed things up during instance lifecycle events. So for example, when an EC2 instance is first coming up, one of the fastest things it does is try to establish a registration handshake with a Systems Manager service. The second that happens and is successful, State Manager associations that are assigned to that instance start executing. So as the instance is still bootstrapping, it's getting instructions to do things like install agents or update and that sort of thing. Run command, very similar, and as you'll see, Systems Manager really builds on capabilities within its own suite. So State Manager is its distinct capability, but it relies on things like run command or automation to do underlying work, right? Like if we need to run a script on an instance, it will do that via run command. And so run command's job is exactly what it sounds like, right? Running commands on an instance, whether that's on-prem or in the cloud. And this allows you to run privileged, complex or simple commands, whether I just want to list directories on a box, or if I want to do very complicated things, anything in between. And so run command is our ability to sort of execute. And one of the things that we'll talk about when I do a quick demo is how to do these things safely, right? I can remember early in my career, there was a time where I was instructed to do some vulnerability management tasks on a bunch of hosts, and this was not at Amazon, but and I made a mistake, and my script ran on like, I don't know, 5,000 servers. And it ended up partitioning off our ability to remotely manage those servers for like 5,000 servers. And it meant that me and my team and a bunch of other people had to go in the data center and hook a console KVM straight into the boxes, right? And it was an important lesson to me, and I was sure I was going to get fired, but my boss told me, he's like, you probably never do this again, right? And as long as that's true, if you learn something, then we're fine. And it's true that like one of the biggest things is that like automation is super critical in our day and age, but it's also that thing that can get you in trouble if you're not careful, right? Running a command on one server is fine. Running it on a million servers is not fine if you made a mistake, right? Or the environment is different, right? Because you can't always anticipate everything. And so one of the things that Systems Manager helps us do is provide safety, right? So what we can do is say, I might want to run these complex commands on a fleet of 10,000 targets or 20,000 targets, and I want you to do them in groupings, say 10% of the fleet that I targeted at a time. And I want you to watch the results of that and say that if you start to observe things that are error cases or abnormal behavior, stop. Don't keep churning away at the 20,000 instances that I targeted. Stop, don't run anymore, and at least I controlled the bleeding, right? I didn't end up accidentally running this all at once at the same time on my entire target fleet. Distributor is, again, builds on run commands underneath, but its job is for us to deploy software packages onto target instances. Again, on-prem, EC2s, doesn't matter. The moral of the story here is you can take an agent or a package of software, register it with distributor, version control it, semantic versioning, for example, and then keep history of those versions and let distributor make some of the decisions for you. So for example, if we want to say, in this use case, we want to install a security agent on a box, I can put that security agent package in distributor, put all of the necessary things like installation scripts for different hosts, manifest files to do things like checksumming and hashing to make sure that the agent is cryptographically the same as it was when I put it in there, and that we can verify that the instance isn't installing something through supply chain injection. And then I don't have to worry about whether I'm on a Windows box or an Amazon Linux box or a SUSE Linux, right? All of them are going to have different install patterns. All I have to do is declaratively say, I want this agent installed, and distributor will do all the things necessary to figure out where did I land, what part of the installation pieces should I be running, and then take extra steps to make sure it works well. And I'll show you guys an example of that today, but it can give you that high fidelity understanding that not only did I just push the package out, but it actually installed successfully, it's running, and the configuration is what I wanted it to be, right? All right, so we'll get out of PowerPoint here. That did not work. 1 second. Wait. There we go. There we go. That's better. Sorry about that. Okay. So one of the first things to talk about, and I kind of mentioned this before, is that when it comes to node or instance management, the agent, the systems manager agent, is sort of the foundational component. It allows us to do all the capabilities that we have. One of the important things to know about the systems manager agent is that it is agent-initiated communication. And what that means is that when an instance comes up and that agent starts running, what it'll do is heartbeat with the service, register itself, and then it will establish what we call control channels and data channels with the service control plane. And what that means is that I will establish a WebSocket channel to Systems Manager, and that's persistent, right? And what I can now do is that when I have work to do as an administrator, I want to run a command on an instance, I tell the service to execute that command, it pushes a message down that channel that the agent initiated and says, you have work to do. right? And then the agent will take that message, spin up a new worker, do its job, and report back. What this allows us to do is that there was never any inbound comms to that instance. I don't have to poke a hole in a firewall. I don't have to change the security group. I don't have to do any of those things. And this will work in an entirely disconnected VPC or network environment as well. If you're in an AWS VPC and you don't have an internet gateway and you don't have an NAT gateway, as long as you put in VPC endpoints, I can talk to this instance as if it did have internet access, even though it can't communicate to the internet at all. And that includes me being on my laptop at a Starbucks in an airport, and I want to get an interactive shell session where we might have called that SSHing before. I can do that via Systems Manager without ever having to worry about port 22 being open or that server doesn't have internet connectivity. I can do it from my laptop. So this is super key, right? This reduces our attack surface on the instances and allows us to do a lot of interesting things. And so we'll talk about one of those things first is this idea behind documents. Of course, AWS is going to publish a ton of documents for you, and Systems Manager, we're constantly launching more and more of these. And generally speaking, these are documents that we found useful for some use case that we've either encountered with customers or we use internally ourselves. But the idea of a document is that it is a structured component that allows us to give a set of commands. They're version controlled, right? So we can have different versions of these as they change over time. There are different types. Like I mentioned before, there's automation, which is like that runbook capability that doesn't have to just be instances. It could be all sorts of things. And then there are command documents, which are run some commands or scripts or code on a node. There are session documents that allow us to do things like interactive shell sessions, change passwords securely, that sort of thing. And one of the great things is that you can actually create a centralized catalog of these documents and share them, right? So if I go look at a document and look down here, I can also provide AWS account numbers and share this account from a centralized account out with others. And so what that means is for certain things, I can have a canonical source of truth regarding, let's say, run books for SREs or agent installations, have one source of truth and then share that out to other accounts so they can run it. But then as I need to update that, I can do that in one central location and it promulgates out. So if we just go run some commands, and again, these documents could take the form of customized installation scripts or what have you, but I'm just going to give you guys a quick example of one, and we're just going to go run some ad hoc shell scripts on Linux instances here. So in this case, I get to tell it what I want it to run, and we might want to go gather some like data on our fleet, like say some hardware. So first things first, I'm just going to check and see if the ls hardware command exists, and if it does not, then I need to install it. Let's see here. And if I make any shell mistakes, don't make fun of me. Nothing like just doing random things live here. All right, so that should work, right? So if the command doesn't exist, go and install it, and then once we've gotten past that, just run the ls hardware command. Now, the great thing is that I don't have to like pipe that to a file and then have that file get copied to an S3 bucket or anything else because Systems Manager is going to take care of all that output for me. Standard out, standard error will get captured as a part of this. So I can just run ls hardware as if I were on the box and know that I'm going to get that output captured. And I can send that to S3 buckets. I could send that to CloudWatch logs, or both, and we'll do that right now. So I'm just going to pick a couple of these instances. And you'll notice, too, I've got a bunch of other instances in here. Some of them are Windows. But Systems Manager is smart enough to know that I'm just running a bash script, and I can't run that against Windows, right? So in this case, it only gave me Linux-capable boxes. I am going to go put this in a S3 bucket. We'll just call this logs. And let me So I already have a CloudWatch log group as well. I'm just going to go grab that, and I'm going to have it stream the output of this to this CloudWatch log group to you. And you'll notice, we won't get into the details, but this log group is encrypted with a KMS key. And so I can trust that like I can put sensitive information in here. and not have to worry about it getting exposed, which potentially if I'm running a command that's going to output some sensitive details that might be relevant. So so we'll just put that in there. Another interesting thing is that you can tie this to SNS notifications. So for example, you could have a document run, and then on state changes like success, or let's say that I'm running this on its 50,000 servers, and I only want to know if it fails. I can tie that to an SNS topic and trigger a notification for each instance that fails, and then I could actually use that as an automation trigger to then go do something else automatically, right? Take some steps, reboot the instance, or whatever, right? So you can really start to leverage these things together quite well. So here we go. We just launched a command against these two target instances, and like I said, it's going to push that message down that control channel and tell these servers you guys have work to do. But we never had to open a port to do this. They're just sitting there polling, waiting for work, right? And so as we can see, they were successful, and here's our output. But if I come out here and look at my CloudWatch log group, I also have that here, right? So there's my LS hardware output from these instances, right? So that's like a basic example of some stuff you could do. Obviously, we're going to talk about much more complicated things, but it kind of gets you used to the concept of what we're talking about here. And one of the great things that we talked about is if we look at State Manager, for example, the only difference here really is that if I had a document that could do this via run command once, what I can now tell State Manager to do is make that happen on either some scheduled basis or anytime you see an instance show up for the first time or whatever, right? And so suddenly I can say, I could test my automation, get a document working the way I want it to, let's say to install an agent or do some work, and then tell it from now on I want every instance to be compliant with this desired state. And so for example, if we look at one of these here, this is telling every instance that exists now and in the future, because what we'll do is say target wildcard, right? Everything that exists and everything that will exist in the future should have the SSM agent running, should be the latest version, and if it's not the latest version, go ahead and update that agent automatically. That lets us have consistency across the baseline of our fleet, right? So that's a very basic example. But one of the things that we talked about too was the ability to control the rate and the safety, right? So if you look here, we can also say concurrency. I can explicitly say how many targets numerically that I want to target at a time, or percentage, like 20% of the fleet at a time, for example. And this is if I start to see, let's say I'm going to target 25% of the fleet at a time, and I want to say that if you start to see 5% error rate, stop what you're doing, right? So that allows me to start to put those safety controls in place and throttle that. And again, logging and all that jazz going out to S3 or CloudWatch logs. So that's basic stuff there. And then as we talked about with distributor before, I'll give you guys a quick example and then we'll turn this back over. But let's say that I have this monitoring agent that we're talking about, and I have a package here that's cross-platform. It's good for Windows, it's good for Linux, different distros of Linux, and I want to install this. As we can see, I've got versions, right? This happens to be 7.18.1. I could have history of these versions going back as long as I want. I could target a specific version for installation, or I can just tell agents, you guys should just have the latest version of whatever I've set for this agent, and I want you to install it, right? So, and I can install this on the schedule or one time. If I hit schedule, it's a state manager association, right? So as you can see, distributor now is just going to take me there and say like, right? Oops. It's done all the work for me. It's already told me I want to install it, what package to install. If I leave version empty, it's just going to go grab the latest version at the time that this runs, which is exactly the behavior I want. And I can just say choose all instances, and I want to schedule this every 30 minutes, because why not? And if any instance doesn't have this agent, consider it a high severity. One of the other great things is I can also tie a change calendar in here. So let's say that I have a change calendar set up that says I have windows where I'm not allowed to do things to instances, like no changes on the weekend, Saturday and Sunday, which happens to be how this change calendar is configured. If an instance shows up on Saturday and Sunday, it will wait and defer this work until that change calendar is clear, right? And so you can run these in default open or default closed modes, but it allows you to actually exercise some more global control too. If I have 50 of these state manager associations, I may say, that's all well and good, but there are still dates where like nothing's allowed to change, and respect those dates. Again, rate control is here as well. Just let this do like 75% of the fleet. And one error. Okay, and as soon as I create that association, the first thing it's going to go do is try to run it now on all the instances that are valid for that target, and we can see that it's found all of my instances, Windows and Linux instances, and it's executing the installation. You'll see one's pending. I let it do 75% of the target fleet, so it picked 3 out of the 4, and those are running as we speak. So I can go get more details on those. And underneath the hood, again, so we had distributor that handles the package, state manager to initiate the installation, and what's happening underneath the hood is a run command is actually running to do the installation of that, right? So that's how they all kind of like work together to accomplish their task. And if we go look at run command, we'll see there's one in progress. And we've already had one that's successful. So if we go look at the output here, okay, so there we go. So initiating the installation of 718, right? It does some prerequisite checks, and then does the injection. In this case, this happens to be an Amazon Linux box, so it did a yum install. It installed the agent, and then we can see that it creates the symlink, all that jazz, right? All the normal stuff, and then it will go out and verify that the agent's actually successfully installed. And running. And now if I go later and do a new version bump of this, say version 8, the next time State Manager executes, it will automatically do that upgrade for me, right? And it will successfully roll back if something happens during that installation process. It won't leave it with no agent. It will roll that install back, right? So that's the basics, and I will hand this back over to Glenn to talk to you specifically about how they're leveraging some of these capabilities in more detail for the agent. So,
Thanks.
yeah.
Do you have the clicker?
Yep.
Thank you.
You bet.
All right, so let's recontextualize. Let's get back to the issue that we are facing. So remember, we have a bunch of accounts owned across internal Amazon, a bunch of AWS accounts, and at InfoSec, the more data we have on those accounts, the better. So we have a bunch of data about the resources, but we want more data about what's going on inside the EC2 hosts, and we're going to get that data by installing security agent software. So that's how we came up with the Host Agent Installation Manager. Again, to recontextualize, we had tried to drive this installation. We had some success, but not as much as we wanted. So what do you do when you can't get everyone to do the legwork necessary for raising the security bar? The team I work on in InfoSec, one of our mission statements is secure by default. We really want users to not even have to think about security. We want them to start building, and the tools that they're using will already have security built in. So for us, the answer to this was pretty simple. We'll just do it for them. We'll drive the installation of the security agents onto the EC2 hosts so we can raise the security bar ourselves. And that's how we came up with the Host Agent Installation Manager. You can see our little manager icon. He's the one making sure that the hosts have the security agents installed. And with this service, our customers don't have to worry about installing the security agents themselves. Like I said, we'll do it for them. As you can guess, however, this isn't a small task. We're dealing with millions of EC2 instances on any given day, and over half of which are spun up and then down within 24 hours. These instances are spread out over hundreds of thousands of AWS accounts, so obviously a big consideration for our solution was the scale. And not only do we have to meet the scale of today, but we also want this solution to have some longevity, right? So we need to make sure that it will be able to scale as these numbers continue to grow. And even throughout the course of this project, we've seen a big increase in the number of accounts and the number of instances. Furthermore, the solution also has to be safe. This might seem pretty obvious, but we really want to make sure that we're not doing any harm to our customers' hosts. It would be a big step back if we're trying to raise the security posture of the hosts, but instead we take the host down by accident. So we really want to make sure that we're not doing any harm. Ideally, our customers won't even have to know that we are there at all. So if we can go in, install the security agent software, and the customer doesn't even have to think about it, then we're golden. Also, I just want to point out, whenever I say customer, this is an internal Amazon project. We view these internal Amazon accounts as our customers, our users, but just to make sure that's clear. The solution also needs to be reactive. So as Eric mentioned, we want these agents to be onboarded to the host as soon as the hosts are spun up, because there's so many that are being spun up and down so quickly, we need to address them as soon as they're spun up. If we had done a polling style approach, like check every hour or so for new instances, we would simply miss too many. And even the ones that we hit, maybe we're hitting them really late in their life cycle. So instead, we want to know about the instances as soon as they're launched so we can react to them and onboard the security agent. And lastly, the solution needed to be communicative. Not only do we need the agent to be able to communicate back to its backend so that we can surface any vulnerability that it finds, but also we want the agent to be able to communicate with us. We need to know that it's installed properly and that it's running correctly, that everything is healthy. So with that in mind, here's our solution. It looks pretty complicated, but in all seriousness, it does boil down to be fairly straightforward. I've broken it down into 3 steps. We've got the resource creation, the event reaction, and the agent installation. And things kind of happen roughly in that order. So naturally, I'll start backwards. We'll start with the agent installation, since that has the most to do with SSM, which is really fresh in your minds. So here's how it works. We've got our accounts. And the first thing we do is create SSM state manager associations in every account. For accounts with existing hosts, the associations are automatically run as soon as they're created. For accounts without existing hosts, the associations are effectively dormant until an EC2 instance is created. And that can be created through the console or through other AWS resources like EMR. Once that happens, the SSM run document kicks in, and it accesses an S3 bucket to pull an installation script, which is a script that we've written to install the agent. It functions for different machine images, and it has boundaries in place to ensure that it's not taking up too much compute power. Then, every 30 minutes, the SSM association runs again, except this time, it sees that the agent has already been installed, so it's not going to try to reinstall it, but rather it'll run a health check to make sure that the agent is still healthy. Logs from all of these actions are constantly being collected, so that's checking the installation status, the installation itself, and the health check. And those logs are stored in regionalized S3 buckets in a central account that we own. So a quick sidebar about logging. The logs are associated with the step that's being attempted by the installation script so that we can easily see what's being done when. It's sort of our way of tagging the logs, so to give us more clarity on the actions that are happening. So get agent config means that we're checking to see if the agent is installed. Install agent package is obviously the installation, and is agent healthy is obviously the health script. We've scheduled Athena queries to set up on the logs to aggregate them. Those queries can count the errors, the number of healthy versus unhealthy agents, et cetera. And then these queries publish to a bucket. And finally, we have CloudWatch looking at the query outputs so that we can be alerted if, for example, we start seeing a spike in installation failures or unhealthy agents. But in terms of the security agent installation step, the heavy lifting here comes down to the SSM state manager. Here are some of the key features that State Manager has that allows this project to succeed. First, start instances. We want this to run over all instances. We have a massive scale with so many instances, and if we had to specify every instance ID that we wanted this to run on, it wouldn't work. There's too many, and they're changing every day. So we want this to run on everything. Fortunately, we can just select a radio button for that. Running on a schedule and running when the instance is launched. So as I've mentioned before, we want this to happen as soon as an instance is launched, but also we need to run on a schedule to make sure that as the instance is live, the agent that we've installed is still healthy. Intake parameters. We are passing some parameters from the SSM association onto the host. For example, we are passing region and account ID. These are really helpful because we can then pass those on to the logs. So if there's an error or if we need help debugging something, we'll have that information in the logs. Speaking of logs, logging itself. This is a really important feature for us. We want to know what is happening all the time. So we can use SSM to enable writing to a specified S3 bucket. And lastly, as you saw Eric use, the max error limit and max concurrency. We really, again, want to make sure that we are not harming our customers in any way. So we use these parameters to assure ourselves and assure our customers that we're not going to take up too much power or we're not going to error their hosts into oblivion. Lastly, in that vein of doing no harm and not interfering, we rely on State Manager's feature of running associations in parallel. That way, if a customer has associations that they've created on their own, we're not going to step on their toes. So a lot of what I've been talking about so far has been the State Manager, but as you may remember, there are actually 3 big pieces for our architecture. And right now, we've only been talking about the agent installation. We also have the resource creation and the event reaction. So the actual first step of this service is the resource creation. We need to create SSM associations on accounts in the first place. That means creating one association per region per account, or millions of associations. We also needed to create some IAM resources. EC2 hosts are associated with IAM instance profile roles, which are associated with IAM policies, which grant the host permissions. We needed these permissions so that we could give the hosts the permissions to run the SSM agent and also the permissions to fetch the installation script and to output their logs to our bucket. Fortunately, we have a tool within InfoSec that'll allow us to mass create resources across these hundreds of thousands of accounts. Obviously, it's an incredibly regimented process with a lot of visibility on it, so we had to be very careful, but we use that to create all these resources in the first place. Secondly, we have the event reaction. When an EC2 host is launched, we need it to actually be associated with the permissions that we've created. We have another tool within InfoSec that does event reaction. So in this case, the event it listens to is an EC2 host being launched, and the reaction is either to associate an instance profile role, if the host doesn't have one already, or if the host does have one, we'll just associate the policy that we've created. And lastly, we need to maintain these resources. So we've created these resources in our customer accounts, which is fine, but that means that we don't own them anymore. Our customers do, and we've been very careful to name them all with big do not touch language, but you never know. I mean, people are playing around. These are accounts that they own. And so we use the event reaction to also check for events that are editing or deleting these resources. And in that case, the reaction would be to cut them a security ticket that says, hey, fix this, put it back in its normal state. For the agent installation section of the service, the SSM State Manager obviously is a core component, but while we were doing the research and the architecture design for this, we did consider some other avenues. First, we considered the obvious option of using our existing internal tools. So what we could have done is we could have relied really heavily on our event reaction tool to not only associate permissions with the host whenever it's spun up, but also to go onto the host itself using SSM Session Manager and then run the installation of the security agents. Technically, that would have worked, but in essence, what we would have been doing is given a single actor permissions to access all EC2 hosts across internal Amazon and run commands on them. So from a security standpoint, that's a bit of a nightmare. That's way too much permissions for one actor to have. Next, we also considered the AWS Systems Manager distributor. So this was also something that Eric showed, and this is something that's really well suited to our use case, actually. It's about installing packages across instances. However, in order to use this, the package would have to be public, and we weren't ready for our security agent to be in a public package. Even if this one was good to be public, we want to make sure that this platform is also ready for future security agents and robust in case they weren't ready to be public. There is the option of using private packages, but in that case, we would have had to specify account IDs, and running at the scale we're working on, and with the number of accounts being spun up and spun down within any given day, that wasn't feasible. All right, let's get into the weeds and talk a little bit about the scalability of our solution. So as I've mentioned, scalability, obviously a big concern, bunch of accounts, bunch of instances. So we've made our service as distributed as possible by having the bulk of the action happen on the AWS accounts themselves. So like I said, the SSM associations are created on those accounts. They're running on those accounts separately, so we've scaled by distribution. However, there's also, of course, some inflection points where all of this comes together, such as when the associations need to fetch the installation script. Or the agent binary, which is the actual RPM of the security agent that we're going to install. This actually turned out to be pretty easy. We store the script and we store the binary in an S3 bucket, and S3 can simply handle the demand. However, as I mentioned, we want to make this scalable not just for today, but also for the future. So we took it one step further, and even though S3 can handle this demand, what we've done is we've created regionalized buckets so that we spread the traffic out across regions. Not only will this enable us to scale more in the future, but it also has the benefit of decreasing the latency. So if I'm calling from my host is in like AP Northeast 1 or something, it will now be going to a bucket created in AP Northeast 1 instead of some other region. So it lowers the latency. We took a similar approach with the output buckets for the logs by creating output buckets, one per region. For S3, there's an interesting feature where you can almost train the bucket about how much API capacity to give you based on how much traffic it's getting. So when we were spinning this up, we definitely did hit some high traffic errors, but the API throughput did auto-scale up to meet our demand. Then in order to scale about reading the logs, we have Athena to look at the logs on a schedule and filter them down to the metrics that we are interested in and store those in a separate bucket entirely to make them easier to graph. Other than the buckets, we also have the calls to fetch the installation script, which have to first pass through our service to validate the caller. The calls come in through API Gateway, and again, API Gateway simply could handle the scale that we needed. We did also, in this case, create regionalized versions of API Gateway to further future-proof this. The calls come into API Gateway, and then a pre-signed URL is returned to the host. The host uses the URL to access the script, and everything else is taken care of by the SSM association. Another important concern that we had with this project was the security. And I'm not just saying that because I'm in InfoSec. Security is everyone's concern. So since this service installs software onto millions of EC2 instances, we really needed to make sure that it was secure. We went over everything as close as possible to make sure that everything was really locked down. For security purposes, I can't get into too many specifics here, but I will tell you about the general things we were considering as we were looking at security of this service. First is encryption. Wherever possible, we are encrypting. At rest, in transit, we're using AWS Key Management Service. So for example, anything being put into or read out of an S3 bucket will have to be first signed with KMS. Everything is audited. Everything we do is tracked and has logs, and we have alarms listening to these logs for abnormalities. Plus, we leverage existing CloudWatch metrics that are out of the box for AWS resources. We have S3 versioning enabled so that if by accident or some malicious actor were to delete some of our S3 resources, we could quickly recover from that. We have digital signature verifications. So when we pull the agent RPM, we really need to make sure that it's the agent that we're expecting. If this was somehow to be replaced with malware, and we install that malware onto all sorts of hosts, that's obviously a big issue. So we use certificates to make sure that the agent is what it says it is. We follow the permission of least permissions, the principle of least permissions, where we have all of our policies as locked down as possible. For those of you who have worked with IAM or resource policies, you know how tempting it is to give something star permissions or to say that something is applicable to star resources. Obviously, we can't do that here. We want to lock it down as much as possible. And lastly, we have a safety switch. This is kind of last ditch. Something's going wrong. We really need to just shut it all down. We have the ability to do that. So in practice, what does this look like? From an end user perspective, the workflow is simple. I go to my EC2 console, or again, whatever I'm using, like EMR, whatever's going to launch EC2 instances. I configure it however I want, and I launch it. In the background, the installation manager will see that an instance has been launched, make sure that the right permissions are associated, and once the permissions are associated, the SSM association will be able to run and install the security agent. If there is a problem with my host, like if I'm using a bad version of some software or my host is poorly configured, I'll then receive a ticket about that resource. I can view the details in an online portal, and I know that I need to fix it. But in case that everything is already right and working well with my host, I don't have to think about it at all. There are, of course, a few special use cases where, for example, we have some accounts that it's super locked down. They won't allow us to use our event reaction tool to associate permissions. But a nice feature of our service is that we don't have to do that. We can rely on them to associate the permissions themselves. So what we've done is we've worked with these teams, and we've told them that they need to create these SSM associations and make sure that any EC2 instances they spin up will be associated with the right permissions, and then everything will just work. Speaking of exceptions, we also had to consider whether or not all of our customers would want the same security agents, or maybe some customer wants a specific version of a specific agent. So far, this hasn't been an issue, since with our rollout, we've only been using one agent, but we want this platform to be scalable, so we want to be able to have multiple agents, and so we'll encounter this in the future. So when the run document first executes on a host, it sends a request to our service to get the pre-signed URL. And along with the URL, we can also return input parameters which are used in the installation script. The parameters can be different per security agent, so we take the account ID when a call comes in. We can determine which agents need to be installed for that account ID, and then return the parameters accordingly. So we could have a flag that says, for this agent, please install, but for this agent, we want no op. We want nothing done. All right, where are we now? We've spent the better part of this year rolling out our service very slowly to all of our internal Amazon accounts, and I'm excited to say that we recently have completed this rollout, and we've therefore met the goal of raising the security bar. This is a big win for us, and we're very excited. Oh, thank you, thank you. But obviously we're not done, are we ever? The main issue that we have left is that due to various service SLAs, there is a turnaround time from the moment that an EC2 instance is launched to the moment that we have the security agent onboarded and publishing data. The SSM association can run the installation script as soon as the host is spun up, but the problem is that if the host is spun up without the necessary permissions, we first have to do our event reaction on that. We need to detect that it doesn't have the right permissions, we need to associate the right permissions, and at that point the SSM association has already tried to run, didn't have the permissions, and then needs to run again, so it has its own retry schedule, and all of that time combined basically gives us some minimum SLA time. And we have seen EC2 instances that get spun up and down within that very short window, even though I'm literally talking a matter of minutes. Fortunately, we have a solution for this, and that's to bake the agent into these machine images. You may remember that I mentioned that this was a strategy that we've tried before, but in this case, we've now really narrowed it down. We know that there's only a small number of instances that we have to focus on, and we're able to approach this problem with a fine point instead of coming at it with a broad brush. And then finally, our last next step is to onboard more security agents. We have one in the pipeline coming up next year, and we've got some ideas about other security agents that we want on top of that. So we're really excited for this service to flex its full potential. I want to thank the SSM, the State Manager team, for working with us and allowing us to do this. A big shout out to the teams in InfoSec who have put in so much work to make this happen, both the team I work on as well as our sister teams. And with all of our effort, we've been able to raise the security bar at Amazon, and we are excited to keep doing so in the future. Thanks so much.